Hi everyone, we are going to talk about exponents today and scientific notation. So we are going to have these rules for exponents that you'll need to understand, not just now, but for on down the line in this class. And notice that I've got some things written up here, expressions such as 5 to the third power and y to the sixth. That contain exponents are called exponential expressions because they're written in exponential form with an exponent. The number that's that larger one is called the base, and then this number is the exponent, the little one that has the superscript. Okay, so when we're multiplying, this is called the product rule, we're multiplying two expressions with the same base, right? So we have a to the m times a to the nth. Then we simply add the exponents. And I can show you why this happens. So let's say that we were taking x to the second times x to the third. Well, that's a total of 5. X is 5 times, right? Because if I wrote this out in expanded form, x times x, there's my x squared, and then x times x times x, there's my x to the third. If you count these, you see that you have x to the fifth power because I have a base 5 times, right? The x is there 5 times. And so that's why this works. It is a shortcut because we don't want to have to write these in expanded form. Just add the exponents and there you have it. Okay, so if you take a look at this first one, we have 3 to the third power times 3 to the fifth power. This will be 3 to the eighth. Now 3 to the eighth is a fairly large number. We're just writing this right now as an exponential expression, so we're going to leave it in this form. If you were going to calculate the value, you could use your calculator and take 3 to the eighth power. A common mistake on when students are working with just numbers is wanting to multiply the 3's and also add the exponents, and you definitely would end up with a much bigger number if you did that. Alright, so let's take a look at this next one. We have n to the first power. So when you don't see a power written, it's an understood 1, and that means n to the first times the 10th times the 12th. So this will be n to the 11 plus 12, so to the 23rd power. Alright, so notice on this next one. Basically what happens here is we combine what we can, right? So we have -7 times +7. We can multiply two numbers, right? Just like we always have. So that would be -49. We don't have another x, so it stays the same. And then we have y times y, which would be y squared, right? Because each of these has an exponent of 1, and 1 plus 1 is 2. Okay, so that's called the product rule. Next, we have the zero exponent. Basically, with this, you need to just understand what is the zero exponent? How do I deal with it? Well, this says if a does not equal 0. So in other words, we can't take 0 to the 0 power. And I'll show you that it's because there's a division involved in this. So a to the 0 power equals 1. And this is just something that you have to know. Now, let me try to explain how this happens. And I'm going to use just some simple numbers here like 2 to the third. Hold on, I had changed that, I thought. 2 to the third power is 8. Okay, so I'm going to kind of show you this progression for us to get to 0. If I divide both sides of this by 2, then I would end up with 2 squared, right? I would subtract 1 when dividing. You're going to actually have that rule pretty soon. 8 divided by 2 would be 4. If I divide by 2 again, then I have 2 to the first power. 4 divided by 2 is 2. If I divide again, then I'm going to have 2 to the 0 power. 2 divided by 2 is 1. And so that's basically where that comes from, right? So it's about division. That's why we can't do 0 to the 0 power. So now this is just showing you kind of how we get to a 0 exponent. You really just have to understand and know this. You could put this on your calculator, you know, like -9 to the 0 power, and get an answer. That would work. But when you're working with variables, you can't really do that. Okay, so -9 to the 0 power would simply be 1. This 3x minus 1, notice it's in parentheses to the 0 power, so that's also 1. Now the next one's a little different because this actually says -5 times x to the 0. So notice -5 is not to the 0 power, -5 is to the first power. And -5 times 1 is simply -5 because x to the 0 gives me this 1. Okay, on the next one, we're going to have 8 times 1, right, because x to the 0 is 1, plus 1. So this is simply 8 plus 1, and that gives us 9. So you can see they can get a little bit tricky. If you'll read it, you know, of course, if we read -5x to the 0, we might not be thinking about that multiplication, and that the 0 exponent does not apply to the -5, and the 0 exponent does not apply to this 8. All right, next. So this is the quotient rule. Here we are. We're to the one I was talking about. When I was showing that progression, you know, that we went through where we got to the point where it was 2 to the 0 power, I was subtracting the exponents. Notice this is saying if I am dividing, right, I have real numbers and I'm dividing a to the m over a to the nth, my a's are the same base. And so in this case, I would take the exponent in the numerator and subtract the exponent in the denominator. And you guys remember that, right? This is the numerator. That's not going to be long enough. Numerator, when I'm talking about that. And denominator. I like to use the terminology and not just say top and bottom, although sometimes I may do that. Okay, so if the bases are the same, I can simply subtract my exponents, and let me show you why. So I'm gonna use a version of this, but not such big exponents. I'm just gonna say, what if we were taking x to the third and dividing it by x squared? If I put this in expanded form, I have x times x times x, and in the denominator it's x times x. Now what happens here is I can remove, right, x divided by x is 1, x divided by x again is 1, and what do I have left? I have x to the first power. If I take 3 minus 2, that's 1, so it's x to the first power, and you know we don't have to write that 1 on the x. We can just write it as x. Okay, so on the next one we have x to the 9th divided by x to the 4th. So that's going to be 9 minus 4, which leaves me with x to the 5th power. And on the next one I have a's and b's, so I can combine the a's and the b's so that I just have 2 terms left. So on the a's I have 12 minus 9, so that's a to the 3rd. On the b's I have sorry, 2 minus 1, so that's b to the 1st, and I'm not going to write the power of 1 on there because we just don't do that. We leave it off. Sometimes you need to think about it, though, right? How does this work out? Okay, so sometimes when students start learning some of these rules, then they try to apply it to numbers, but 24 and 10 are still just 2 numbers that we need to simplify. We're not going to take 24 and subtract 10 because remember the subtraction is about the exponents. Okay, so 24 over 10 does simplify, and we will simplify it. I'm just going to write it this way. Okay, so on the a's I have a 10 and a 1. So that's going to be a to the 9th power. And then I'm going to have b to 11 minus 3 is 8. Now let's look at this number. 24 and 10 have a common factor of 2. So I'm going to divide them both by 2. So 24 divided by 2 is 12. 10 divided by 2 is 5. And then I can write this a couple of ways. So I can say 12/5 times a to the 9th and b to the 8th. You want to make sure it's just written to the side. You don't want those to look like they're in the denominator. Or I can write it as 12 a to the 9th b to the 8th over 5. And then that's it. If I can get this to look right. Okay, put it a little bit lower. All right, so that is it for that one. You just kind of work with these on how you need to. Numbers with numbers, my A's and my B's. Okay, so now we're on to some negative exponents. We'll go ahead with this. We'll probably stop after this slide and go on to the next one. So I'm going to go back to that progression I showed you earlier, because notice what this says. A to the negative n equals 1 over a to the nth. This is a common way that we're going to write this. But here's why. So let's start with 2 to the 0. Remember that was 1. If I divide by 2, I'm subtracting my exponents. 0 minus 1 would be 0 to the negative 1. 1 divided by 2, remember we're dividing by 2, would be 1/2. And then if I do that again, I'm subtracting exponents, so I have 2 to the negative 2. 1/2 divided by 2 is 1/4. Notice that means 2 to the second power is in my denominator. And so there are other things we'll talk about as we go, but that's our basics for now. We rewrite negative exponents by writing them in the denominator with a positive exponent. So on this first one, that would be 1 over 2 to the 3rd power, which is 1/8. We'll go ahead and simplify that. On the next one, this would be 1 over -6 to the 2nd power. So that's 1 over 36. And then the next one would be 10 times 1 over b to the 1st. And we would just write that 10 over b. Now we'll do more with negative exponents as we progress through this lesson and the next lesson. So I'm going to go ahead and stop the video here, and then we'll pick up the rest of the lesson. Possibly we'll have to have 2 more, we'll see, on another video.